All right, this is the last video on the review of how to do statistics using Excel. And the last thing we're going to do is run a regression analysis. Regression analysis is done through the data analysis tool pack again. So go to data, data analysis, and we're going to come down here and do regression this time and click OK. All right, now remember when we do regression, we have both independent and dependent variables. The independent variable is called X. This is the thing that is considered either the cause or what comes first. And the dependent variable is known as Y, which is the effect or what comes later. So in this case, because students pay their tuition first and earn the salary later, it means that the tuition and fees is the X variable, the independent variable, and salary and bonus will be the dependent variable or the Y variable. Okay, now the way Excel has this set up, the Y variable comes first. So it says input the Y range. So we're going to click on the little arrow there. And when you're doing regression analysis, you do want to include the label. And so since our Y variable is salary and bonus, we're going to highlight everything from the label all the way down to the bottom of the numbers. Okay, click the little down arrow, and now we need to do the same thing for the X value, which in this case is tuition and fees. Okay, now we want to make sure that the labels box is checked because we did include labels, and the regression analysis is a little hard to interpret without the labels, so we want that checked. And then we want to not check constant is 0. What constant is 0 means is that it would actually force B0, B0 to be equal to 0, and we don't want to do that, so leave that blank. Then we want to click confidence level for 95%. This is going to give us some margins of error for our confidence intervals based on a 95% confidence. And then we want to put it into a new worksheet because this one's getting kind of full. So we'll put a new worksheet called regression. So leave that as new worksheet. And then we do want to get residuals, and we want to get a residual plot and a line fit plot. So check those three boxes. We don't need the standardized residuals or the normal probability plots. We didn't really get into that in too much detail in this class. All right, do all that and click OK, and that's it. Your regression analysis is done. Certainly a lot easier than doing it by hand with the calculator. And we need to do a little bit of formatting so that we can understand and interpret all of this, but that's how you do regression analysis on Excel. All right, so first of all, let's expand column A here out a little bit so that we can see what's going on a little bit better. And what we see is some regression statistics up here. The multiple R, what is called multiple R, is actually the same for simple linear regression as the correlation coefficient. If you remember correlation coefficient, if you remember, the number was about 0.86, and that's the same number that we got here. Now, in multiple regression, that's not going to be the case, but in simple linear regression, the multiple R will be the same thing as the correlation coefficient. The R squared is just the square of the correlation coefficient, and this is the same R squared that we calculated in class. So in this case, it's about 0.74. What this means, again, is that 73.67, or about 74% of the variation in salary and bonus can be explained by variation in tuition and fees. And we'll fix that in a minute, move these plots out of the way so we can read this. We'll be looking at these plots over here later. Oops, what did I do? Move the title to the wrong place. Okay, so you can ignore this adjusted R square and standard error. We aren't going to use those for anything. The observations is just the number of elements in our sample. So it's the sample size. This is little n equals the sample size. Okay, down below, what you notice is a ANOVA table. And in order to read all of this, clearly, we're going to need to expand columns C and D a little bit so that we can see what's going on. Okay, the ANOVA table has the degrees of freedom, SS, which stands for sum of squares, MS, which stands for mean square, and then the F statistic, and then what it calls significance F. Significance F, let's expand this so we can read it, is what we've been calling the p-value. Okay, so significance F here refers to the p-value. Now, there are labels on the rows for regression, residual, and total. Now, what they call residual in Excel, we call error. And the reason that we call it error rather than residual is, of course, that if you have SSR and you call it regression and residual, you wouldn't know which one it was referring to. So we call it SSR for sum of squares due to regression, and MSR for mean square due to regression, and then SSE for sum of squares due to error, and MSE for mean squared error. So what they call residual in Excel is just the same thing as what we've been calling error. The degrees of freedom is what we've been talking about in class. The regression degrees of freedom is always 1 for simple linear regression. The degrees of freedom for the error is n minus 2, which in this case would be 18, and then the total degrees of freedom would be 19. Under here, under the p-value for the significance of F, you notice that it's in exponential notation. What this means is that there are 6 spots that you would need to move the decimal point over. In other words, there would be a decimal point and then 5 zeros and then this 1. Obviously, that's going to be much less than alpha. 0.00001 is going to be less than 0.05. So it means that we are going to have a significant relationship between these variables, and we will reject the null hypothesis that says beta 1, sorry, is equal to 0. Okay. Down below, we see the coefficient for the regression, and what it calls the intercept coefficient. This is what we have been calling B0, B0. And the coefficient for tuition and fees, this is what we have been calling B1, which is the slope of the regression line. So in this case, the intercept is 34,002. The slope of the regression line is 1.911. The standard error here, this number 0.269, this is what we have been calling S sub B1. And I'm just going to type SB1 in here for us to remember that. What they call the t-stat, we aren't really interested in the t-statistic for the intercept, but this is just the t-statistic that we calculated for the slope, which is equal to B1 divided by SB1. So if you calculated that, if you took this B1 number, this 1.911 is actually B1, then if you took that number and divided it by this number, you would get this number. That's the t-statistic. Okay, the p-value then is the p-value for this t-statistic using the correct number of degrees of freedom. And this is for the hypothesis test that says beta 1 is equal to 0. And in this case, as we've noted, in simple linear regression, when there's only one variable, the p-value from the t-test is the same as the p-value from the f-test. So we're going to reject the null hypothesis with the t-statistic the same way we rejected the null hypothesis with the f-statistic up here. The lower 95 and upper 95 numbers, this is the confidence interval, a 95% confidence interval for beta 1. And I don't know why it's repeated twice on here, but it is. Okay, so we can now put in our final results from our regression analysis. And the way we would do that is we could type here y hat is equal to 34,002, which is the B0 number, plus 1.911 times X. This is our regression equation. And the trend line that we calculated earlier on the scatter plot, this is the formula for that trend line. Remember, it's y hat because that is the predicted value. It's not the actual value of y because there's going to be some errors. But this is the predicted value of y for a given value of x. Okay, so what does this mean in business terms? This is the statistical result, the regression equation. In business terms, this means that we expect that, or we predict, let me put it that way, we predict that for every increase of $1 in the tuition and fees, salary and bonus will increase by $1.91. So what do you think? Is this valid? Well, we've got statistically significant evidence. We rejected the null hypothesis that it was equal to 0. So therefore, we predict that if you pay $1 more in tuition and fees, your salary and bonus will go up by $1.91. So is it a good deal to go to a more expensive business school? Well, this data would certainly seem to suggest that it might be. Okay, now we also have a confidence interval here for beta 1, and we can say this in statistical terms by saying we are 95% confident that beta 1 is in the interval of 1.345 to 2.477. Okay? And what does that mean in business terms? Well, the way we would look at this in the business terms would be, we could say, we are 95% confident that every additional dollar spent on $1, let me put it that way, $1 spent on tuition and fees is associated, let me put this on another, oh, I wonder why it did that. I guess it's because those other these other things were in italics. Okay, let me try it again down here. We are 95% confident that every additional $1 spent on tuition and fees is associated with an increase in, on the next line here, salary and bonus of between $1.34.5 to $2.47.7. All right, that is how you interpret the coefficients of the regression. The last thing we want to look at now is these tables or charts that we've got over here. So we've got a residual plot. We're going to expand this out a little bit. And we can see that the residual plot and the line fit plot are created for us. And the line fit plot just shows us all of the original data in blue and the predicted data, the values of y hat for each of those in red. So you can see how good a relationship there is between the prediction and the actual values. The reason we look at the residual plot is we want to see whether it has a nice distribution. And in this case, it looks kind of like it might have kind of a U-shaped distribution, which is not ideal. So we could say something like the assumptions of the regression model appear to be fairly well applied, I guess. But there is somewhat of a U shape, and we can say this may indicate heteroscedasticity. So variable transformation may be appropriate. Okay, now we're not going to get into actually doing the variable transformations in Econ 5. However, this is something that you'll learn about if you go on to more advanced statistics. And regression analysis is usually not just a one-time thing that you do. You actually do an iterative process where you try out various things and see what seems to work the best, what seems to be the best model that gives you the results that seem appropriate. So it's somewhat of an art in addition to being a science. You can't just plug in numbers into a formula and think that that's the final answer. Okay, so that covers a review of the entire class and how to do the same things that we did manually on Excel. Now, what you want to do is follow along and do the same thing with the San Antonio housing data. The practice exercise is attached to the end of the instructions for the this this video, and I want you to do it yourself. Send the resulting Excel file back through Canvas as part of your Canvas homework grade.